Hello and welcome. 24th of September 2014 is a day that will go down in our history as a day when our scientists were able to do something that few people thought that they could realistically achieve. Place an Indian-designed, Indian-built satellite into an orbit of Mars. Now, everybody knows that India is a fast-developing space power. Now, that's nothing new. But to successfully place a satellite into Mars orbit in its very first attempt is not just a record, but an indicator of a system that works. And by working system, I'm not just referring to Mangalyaan, I'm talking about the institution that built Mangalyaan in the first place, ISRO, the Indian Space Research Organization, and the men and women behind this remarkable scientific engineering feat. Today, a very special program when we bring together some of the finest minds in the country, Team ISRO. Joining us, Dr. Radhakrishnan, he is the chairman of the Indian Space Research Organization. Dr. M. Annadurai, next to him, program director of Mangalyaan. Mr. S. Arunan, the project director of Mangalyaan. Dr. V. Kesava Raju, mission director, again with Mangalyaan. Dr. Anil Bhardwaj, to his left, director, Space Physics Lab at the Vikram Sarabhai Space Center. We're also joined by Mr. Shomo Sarkar, associate project director at the Space Applications Center. Thank you very much for being with us. And also with us, a wonderful audience over here. They are some of the finest young minds in the city. Students from various schools, DPS Arkepuram, Bluebells, Yaravari College of Engineering, Sanskriti School, NIT, and the Shriram School. And they've got questions for all of you. And of course, I wouldn't be able to do this program without my friend Pallav Bagla. He's written a book on Mars. He has written a book on Chandrayaan as well. He is one of our foremost, if not our foremost, science journalist and an inspiration for me. So I'd like to thank all of you for joining us. Dr. Radhakrishnan, let me come to you first. Mangalyaan, is it behaving itself?
Yes. The Mars orbiter spacecraft is doing well, and the 5 instruments are doing their job.
Okay. So you have validated several technologies: propulsion, the design, communications, the sensors. What next as far as ISRO is concerned?
But the most important thing that we needed for this mission is the autonomy provided to the spacecraft to take decisions on itself without waiting for the command coming from the ground, because it takes almost 12 minutes for that to reach the spacecraft. So that has been a major achievement, and this will be used in the future spacecrafts too.
So essentially, this is a smart system. It thinks for itself. How does it do that? Is it very complicated software? What are some of the... How did you actually make it as smart a system as it is?
Normally for a spacecraft, when we operate that, the ground controllers look at the health and send also commands from the ground. Here, because the time is too much to have that, the spacecraft is provided with decision-making capabilities.
Right.
It looks at the health of certain instruments, and if need be, it switches over to the standby system. There are certain operations to be done where a sequence of commands have to be given. Once we trigger that, the rest of the commands which are stored in the satellite are automatically taken care of. So these are some of the provisions available. And finally,
yes,
if the spacecraft gets into a serious problem, and you need the people on the ground to seriously look at it, there is a safe mode. That is, satellite would be looking at the Earth for commands, and the solar panels will be looking at the sun, so that energy is there, and you are able to take the commands. So far, we have not gone into that mode.
Well, let's hope that you don't need to use that mode. Before we carry on with this discussion, let's take a look at the Mangalyaan project and the journey, the remarkable journey that the spacecraft took from Earth, from ISRO, all the way to the orbit of Mars.
The rocket that carried India's first unmanned satellite to Mars was as high as a 15-story building and weighed nearly 320 tons, the weight of about 50 full-grown elephants. One after the other, 4 stages of the rocket ignited, taking Mangalyaan higher into space. The Mangalyaan first made several revolutions around the Earth as it gathered enough velocity, and then it was shot onwards to Mars on its long journey. It took nearly 9 months to cover the over 200 million kilometers to reach its destination near the Red Planet. Once Mangalyaan is close to the Red Planet, it is reoriented. The satellite's onboard rocket motor is fired for several minutes, slowing down Mangalyaan sufficiently. The gravity of Mars then captures Mangalyaan. Then, in a highly elliptical orbit, it will revolve around Mars, conduct several experiments over a period of 6 months, announcing India's big leap to the world.
And that big leap actually continues till this day. It's operating fine. Dr. Annadurai, let me ask you this. Now, it cost you about $74 million US for this mission. Yeah. Now, the cost of NASA's Maven Mars mission is about $671 million. Now, this has been discussed ad nauseum, you know. But the point which perhaps is not made is that cheap or less expensive doesn't mean it is any less high-tech. How have you managed to use the state-of-the-art while ensuring that your budget was the minimum possible?
Yeah, this is a very, very cost-effective mission, what we have realized. But still, all the requirements for the first time going for the Mars, and again making it successful to that mission is concerned, all the ingredients have been built in here. We have all the lessons learned from our own mission, even elsewhere what happened, all the lessons learned have been accordingly accommodated here, such that we have everything okay. But notwithstanding that, what we have done is, majority of the elements here, what we have taken is inherited from the previous missions, such that we are able to get the already heritage systems, well-proven system, tested system. So nominally the mission cost is more than developing the system and testing the system, then accommodating. The first two elements already, ingredients already with us. Then over and above that is a mission of this caliber calls for manpower is more costlier. Yeah. I think, you know, Indians are second to none, everything is concerned. But I think we are, overall, we are cost-effective manpower and puts more effort and more time. The manpower puts all the efforts such that this is the national pride, the once-in-lifetime opportunity. Absolutely. Everybody felt once-in-lifetime opportunity. We should show, yes, we are in the history making. I think this whole thing.
You have created history, so there's no more history making. You've made history. Mr. Arunan, what was going in your mind as you looked at the clock and you could actually do nothing because it takes that 12 minutes? Orders had been given, instructions had been given, commands had been given, and you were waiting for the craft, after realigning itself, to fire its thrusters so that it could enter the orbit of Mars. You could do nothing, True. Right? You could just watch and read consoles. True. What was going through your mind?
See, from day one, to be frank, we were confident that the culmination, the Mars orbit insertion, will be 100% success. There were hair-raising tension moments when those kind of scenario which you described were there. But all along I felt throughout the mission that this moment is a moment where I was living my dream. Okay, so it was like, I felt like I was living my dream.
I remember your recalling telling me that in the 15 months in the run-up to the making of the Mangalyaan, you're a James Bond fan. That is one of your fascinating points. But is it correct that you really slept 15 months in the satellite center? Yeah. And what were you doing in the spare time when you used to go out of the satellite center?
So we have, because the schedule given by our chairman is 15 to 16 months of time to realize the spacecraft and take it to launch pad. And definitely without 24/7 working, it is highly impossible to achieve the target. With the new mission elements, new technology elements, testing of those elements, simulation results. And we have taken a decision that we will not compromise on any of the testament for that, irrespective of the time crunch we have. So which forced us to work almost 24/7. So as a team leader, yes, there were subsystem people who worked on 7-hour basis. But as a team leader who acts as interface between all the team members, I have to be in office almost all the time and sleeping in my room.
I think that really is a message for you. The finest scientific and engineering minds, they've done the calculations, they've thought it out, and yet at the end of the day, it's that effort of physically being there and getting the job done that counts so much. Is there a question?
Yeah. So I'm Alankrit Tomar, I'm from Sanskriti School. Sir, I read a news report which said that only 2% of the IITians and the NITians are part of the ISRO. So what should be done in order to encourage these engineering graduates to pursue research in aerospace and not move out to other countries and work there?
What we require is people who are committed to get into the cutting edge research and, as mentioned, slog and also produce such kind of exciting results. This is what we require. And once that is available, I'm sure the best brains will stay back and do that job.
Well, you know, there is a message, and all of us are fans of ISRO and what it stands for. But we actually took our cameras out and got a few more inspirational Indians, unrelated to science, unrelated to ISRO, to speak about what Mangalyaan, what the space mission, what ISRO is all about. This was Sunil Gavaskar. This was his message to all of you.
Oh, I think it's an absolutely tremendous achievement by the Indian scientists to have done what they have. It is, you know, it's mind-boggling, and to think of the cost that they have done it at, which much less than say similar other missions. I just want to congratulate them. I just want to say to them, well done, and that you make us very proud.
Dr. Kesavaraju, let me come to you next. Mangalyaan is not going to last forever in as much as we would like it to. Its life is determined by the amount of fuel it contains on board. How much longer is Mangalyaan actually going to be around doing what it is doing? Because I'm told you actually managed to save a lot of fuel on board. You were supposed to end up with about what, 40 kilograms, and you've got more. Or I mean the other way around. Yeah. You expected 20, you've got 40.
Yeah, correct.
So how much longer can we expect the spacecraft to keep functioning?
Actually, the amount of fuel what we need to spend is very little, maybe of the order of 2 kg per 6 months of that order. Also, after the completion of the prime activities, one can think of to have a better observation from these payloads. Also, we have enough fuel presently of that order of 40 kg. So it is not going to limit life to the 6 months. The first expectations are that our systems are working fine. The fuel is not going to be the limiting factor for the life. We can make more observations for a longer duration.
So we can count on it being there for a few years?
Yeah, it is possible.
Right.
But that is very big news that Mangalyaan can last several years. That means he'll last longer than Maven. Maven is supposed to last 1 year. So we may outdo NASA in that also.
At what, 1/4 the price?
Wow, outstanding.
This is very interesting. Dr. Bhardwaj, you know, since you handle a lot of the scientific, you've handled the scientific payloads and things like that. Now, again, for those who are cynical of ISRO, they'll say, oh, look, yes, of course, they've managed to reach Mars, but, you know, they've only carried 15 kilos of payload on board. But it's the choice of what you have carried which is important. And I'm told the methane sensor that you have on board is important because it could ultimately add to the science on whether or not there is life on Mars. How is that the case?
Okay, as you all know, there are 5 instruments on board, and methane sensor for Mars is one among them. Methane, if you look at Earth, methane is produced by biogenic activities, that is biological activities, almost like 70 to 80% of the methane. So that means if you have a presence of methane on Mars, it will hint to the presence of life. Life doesn't mean human beings, it could be any part of life, like even bacteria or viruses or fungus or algae also produces several different gases. And if we get a hint of that, it will indicate towards the presence of life. It will not be 100% sure, but it indicates that yes, life could be there on Mars. Right. If you look at the orbit of MOM, it is very unique. We are going almost like 300 or 350 kilometers close to the Mars, and then we go almost like 70,000 kilometers away. And we are in the equatorial orbit.
Right.
If you look at previous missions of Mars, mostly they are they are polar orbiting. That means they go from North Pole to South Pole. Okay. Whereas we, for the first time, has gone into equatorial plane.
Right.
So we are going to sample the Mars in the equatorial or low latitude, which you say, which has not been done by other previous missions. So the choice of the instruments was based on the orbit which we had, because we can radially sample. Similarly, if you go like 70,000 kilometers away, you can take the whole picture of the Mars at the sunlit time. which has been already coming in the...
That's absolutely remarkable.
So
we are seeing Mars in a way that has not been seen before.
Right, absolutely.
All right.
Anil, any results which you've seen now? Your instruments have been working there. You had the Comet go by. Now, can you tell us what has come about from your instruments? Have you sensed some methane till now?
We are still working on the analysis of the data right now because it needs very depth analysis before we really reveal out the science results. So we are working towards it. We are actually looking at what happens when the comet had a flyby of Mars. That is the comet sighting spring, which happened on 19th of October.
But what can you share with us on this data?
Not exactly to the point, but yes, we are seeing some interesting signatures.
Of what?
Of gases. And we looks like we see that when the comet passes through the Mars, we are able to sense some of those indications. But we have to look into depth to actually understand it. So it will take a little time because
and if you are able to
tell
if the data proves to be correct, what would it be an indicator of in terms of the gases which you feel that you have traced?
One thing is that actually the data analysis that has been going on in MCC images, we have been able to see actually some sort of dust devil building up. So those kind of pictures are there. We are looking into the data, and subsequently this observation will be released.
You know, one of the very interesting aspects that Pallav interested me was on the day the launch took place was Twitter, and how ISRO was using a pretty easy to use technology when they've actually gone and done so much more in space. And you were actually part of the team that was tweeting. And just give us the numbers. In the first 1 hour, you had how many thousand people following in? And this was an early morning launch, so it wasn't.
It was into lakhs actually.
All right, so how many people? 260,000?
Around that time only.
You had 260,000 followers on Twitter in how much time?
Within a day we got that first number. That is for the first person tweeting account.
That's unbelievable, absolutely.
Yes.
That is absolutely remarkable. Ansa, you would agree that this gives you an idea of how many people in this country are interested in your success.
One thing I just wanted to mention when we talk about the spin-offs from this mission. On October 22nd, 2013, we decided to get into the social media so that we can communicate directly with the younger generation especially. And as of now, we have 8 lakh likes. And this social media, Facebook as well as Twitter accounts, are handled by 3 young scientists. And we wanted them to be sharing the mindset of the younger generation. And it has been quite successful. They discuss physics and mathematics or the whole activity on the social media.
That's absolutely incredible. You're talking about young minds, and we've got another young voice out there. Ranbir Kapoor spoke to us some time back on what he thought of ISRO and the Mars mission.
Hi guys, this is Ranbir. I just want to wish you all the best and more power to you, to the people behind the Mars mission, and I hope that you guys have a great journey from and back to the Earth.
All right, from and back to the Earth. Is that actually something that you will ultimately also look at? You know, you've reached the orbit of Mars at this stage, but in terms of a rover or a craft on the surface of Mars, or perhaps the moon, is that where ISRO is heading next?
The next step in the area of lunar and planetary exploration are the following. 1. On the moon surface, we want to have in situ measurements by putting a rover, and we need a lander that is being developed. The second aspect of is what next with regards to Mars exploration and when we can do that. 2016, which is the next opportunity, is too early for us. So 2018 or 2020, we need to have a good scientific mission. That's what we are aiming at. Whether it is an orbiter, whether it is a lander and rover, this is to be firmed up. There's a scientific community which is looking at that.
Do we have the technology for a lander on Mars?
We are developing a technology for a lander. What does it mean? From an orbiter, you need to bring that instrument down to the surface. First, it has to be a soft landing. That means we reduce the velocity. The second one, you need to land exactly where it is landable. That means you have to take pictures and steer the craft in such a way it comes. And of course, the mechanisms. So when we do the Chandrayaan 2 lander development, I would say we would have reached a good position. Then the communication, all aspects related to the Mars are to be tackled. The Curiosity is the recent example where they did successfully. But first step for us is to have the lander technology.
Do we have a prototype of a Mars lander?
We are now on paper with the design, and we have to translate that into actual reality. Maybe about 3 years' time, we should have the working instrument that could be flown for the Chandrayaan-2 mission.
So what you're telling me, Dr. Radhakrishnan, is that 2018, India can expect another mission to Mars.
I won't say that today, but soon I think the scientific community would come up with what they would like to investigate as a major scientific mission. The Mars orbiter mission MOM that we had now is essentially a technology mission that is to orbit. That we have learned. Next mission should be a sizable scientific mission. It could be either of this.
Go ahead, the gentleman over there. Yeah, go ahead, yes.
Yeah, so of course we have had lunar missions, as we know, and now we have moved on to Mars. So is there any special evidence that supports our claim that we can possibly have life on Mars, and are there any more projects that we are thinking of to go to other planets or stars such that we can find habitation on them or we can establish settlements on them?
In the area of space exploration, we are looking at Moon, we are looking at Mars. As far as the life on Mars is concerned, the instruments that we have, that is the methane sensor as well as the thermal infrared sensor, together should give some evidence or presence or absence, and if it is present, what is a possible source.
Anybody else? Yeah, go ahead.
As a part of youth, I would like to say that there should be a healthy majority of youth in the dream team of this MOM.
You want young people to be involved in ISRO?
Involved in the
Let me just address this like this. ISRO family consists of 16,000 persons. Of the 16,000, nearly 10,000 are scientific, technical persons. We have nearly 4,500 of them, scientists and engineers, who joined since the year 1999. That means 35 years and below, we have 4,500. It's a huge number. And if you see the pictures of that Mission Control Center of Mars, you will see all young people taking responsible positions, responsible jobs.
Anybody else? Yeah, go ahead.
Sir, I'm Vinita Sharath from Sriram School teaching physics there. I met you 2 years back in Bangalore, and I asked you a question, sir, that what should be the role of teachers so that children at young age can be motivated to take pure science and join as scientists. You said, ma'am, you just spread this type of things and you get exposed to children to this. That we all are doing. But the problem is that are we allowed to visit the center so that children can have, you know, first-hand information from, let's say, Vikram Sarabhai or Sri Harikota?
It is essential and we welcome that.
Thank you, sir.
Yeah.
Thanks a lot.
Basically, we feel the teacher ignites or puts that seed into the mind of the student what they should do in the future. So you can do a lot, teachers and the students. See a launch.
Mr. Arunan, I wanted to ask you this, and this is what I've been told about ISRO, the working culture of ISRO, where you've got senior scientists like Dr. Radhakrishnan, you've got the youngmost scientists, and there is a culture of asking questions, that there is no wall, there is no glass ceiling, there is no bureaucracy when it comes to asking questions. How does that actually work? How do you encourage young minds to ask the questions that they want to ask on scientific projects?
So, from the day I joined ISRO, 85 onwards, basic culture is, as you rightly told, asking questions from any quarters, from engineer to a top management is welcome, and it is taken in a positive manner, which is a basic strength of the ISRO, according to me, today. Even with respect to Mars mission, some media told that chairman discovered me. I will say he invented me. See, he was hand-holding us from the day we submitted the feasibility report, we started the project, till we reached Mars. My hands are with him, which means such a kind of motivation and moral support and asking questions and getting reviews done and answers back. These are all the basic strength on which ISRO lives today, and ISRO gets a success, according to me, because of this culture.
Questions, anybody? Yeah, this gentleman in the red shirt, yeah.
So we are spending around $450 million for this project. So what is the use of it? Means we should use this particular amount of money for establishing communication system for our Earth, means India. So, but we are actually exploring Mars.
So you're asking, and this is a fairly common criticism, that, why are you going to Mars when there is so much to be done over here? How would you respond to that?
First and foremost, if you look at the space program in the country, it is towards the society and the people. And what we spend annually for the space program is nearly $1 billion, which is about 7,000 crores at the moment, which is something like 7.5% of what NASA spends on its program. That's one part of it, which is, as compared to the central government expenditure of India, it is 0.34%. This is one aspect. If you look at where this money goes within the ISRO system, 7 to 8% only goes for this exploration activity, Mars or Moon or such activities. The remaining are going towards satellites, launch vehicles, specifically looking at the society and the applications required for that. So that is one answer. The second part of it, when we do this exciting science on one side, it drives the technology. For example, the autonomy that we built into this Mars orbiter spacecraft is going to make our remote sensing satellite smart satellites. That means they are going to be more effective for the future. That's a technological spin-off coming out of it. And if you look at the returns that the Indian space program is giving to the government and the people, it is much, much more than what it is taking from the exchequer. And if you look at the recent cyclone that happened, the lives that we could save because the early warning provided, because the satellite could take those pictures well in advance, that itself justifies the kind of activity we do for space applications towards society and people.
Would you like to tell us a little bit more about, we've spoken about Mangalyaan. Let's talk about satellites and let's talk about rockets. Okay. This program has all been about the satellite, but the satellite needs to get up there, and that's the rockets. What we have achieved through the PSLV is a level of consistency which is absolutely remarkable. Tell us a little bit about, firstly, the PSLV.
Yeah, PSLV, you recall, originally for the remote sensing satellites to put, I think, first 3-4 satellites went from Russia. Then it's a self-reliant point of view. The first we started with the PSLV, now is a polar satellite launch vehicle. To start with, for the remote sensing satellites, I think first one only experimentally we had an issue. But having understood what is the problem, having learned what is the issue, and all the subsequent missions, everything has gone okay. But in spite of that, I think every mission, I think the lessons learned, I think we have another thing is post-flight analysis. Every mission, even though success, we have seen the success, but still there are lessons learned from each one of the missions. I think those lessons also have been built so that the perfection, engineering point of view, perfection is the one which always eludes you. I think the PSLV is the one which every launch you inch towards the perfection. I think today when we are putting the launch vehicle is good enough to go to our satellites towards the Mars. I think it is almost inching towards that so-called perfection in that point of view. That way, I think today we can tell with all the modesty, with all the humility, I think a PSLV vehicle, even though it's called a polar satellite launch vehicle, it does many functions. For example, many of the geo missions like Kalpana mission.
Is it the finest rocket of its class in the world?
In this class, I think today we can rate technologically, I think the finest mission, and economically it's finest mission. And it's whatever it is shown in the record, also shown definitely it's the finest mission in this class of launch vehicles.
Go ahead, yeah, and then Pallav.
I'd like to ask you something. Now, ISRO has gone on record to say that more than anything else, the Mangalyaan mission was a capability test, whether we can attempt and succeed at interplanetary travel, and you guys have managed to do it brilliantly. But what I want to ask you is that do you expect the Mangalyaan to discover something and surprise us all, just as Chandrayaan did? It discovered water on the lunar surface, even though the lunar surface has been so well explored by the Apollo missions before. But it came up with something so new and it left us all dumbfounded. So what is your expectation?
The primary objective was to orbit a satellite around Mars, which we have done. And we say 85% of the mark we have got. The remaining 15%, that is to be done by the scientific instruments. Suppose this methane sensor is able to tell us something. That's something great. The presence or absence of methane. So these scientific discoveries would probably be coming in the coming months.
Dr. Bhardwaj, can you tell us whether we are going to have exciting stuff in the next few months? Because you're indirectly And I know there is a process of scientific review and all of that, but are you confident that there will be something very exciting from us from, say, that methane sensor?
Not only methane sensor, there are other instruments also which are also exciting in Mars mission. And we are all looking at all the 5 instruments data now. And hopefully, yes, what I can say as of now, we are seeing some interesting signatures, but we have to confirm it. And it's a procedure. So we have to take time and understand it better.
So what, 2-3 months?
Couple of months.
Couple of months, easily.
Yeah.
Dr. Radhakrishnan, now, not many know that when you're not flying rockets, you sing devotional music, you do Kathakali, you tamed the naughty boy, which is the geosynchronous satellite launch vehicle Mark II. Tell us a little bit more about this monster rocket, the geosynchronous satellite launch vehicle Mark III, which is sitting on the launch pad. Yeah. In the next few weeks, we'll see it going up. What will it do? What will it carry? Is there excitement?
Yeah. See, the PSLV is a versatile rocket, a reliable rocket, which has done several missions, as Mr. Annadhuri pointed out. It can put nearly 1,300 kilogram class of satellite into a geostationary transfer orbit. The GSLV D5 that we successfully flew with our cryogenic engine in January 2014 can put about 2,200 kilogram. But we need capacity for putting larger communication satellite. GSLV Mark III will take us to 4,000 kilogram. And we are going through an experimental mission of that GSLV Mark III, and it is expected to happen in December 2014, next month. The vehicle is already integrated at the launch pad in Sriharikota. Also, there is a crew module which is going in as another experiment in that. So it's a 2-in-1 experimental mission. The crucial atmospheric phase of the GSLV Mark III would be tested. It will take the crew module to an altitude of 120 kilometers. From there, it will be ejected. So during that re-entry, how does it behave? This is going to be studied. This is going to be a very major technological milestone for the country.
So how many astronauts are you carrying in the crew module?
This is an unmanned crew module. If you look at the crew module from outside, it will be similar to what we would probably have for the future. It can accommodate about 2 to 3 persons in the final shape. But what we are now doing is only looking at the re-entry and the thermal behavior, how is it able to withstand the thermal fluxes at the time of re-entry.
See, if the government gives you a go-ahead, you ask for 12,500 crores. It's a large sum of money, but India is a large country, and Modi has an even larger heart. If he gives you a go-ahead, in how many years can we see an Indian astronaut being launched from Indian soil on an Indian rocket? You may not be the chairman, but somebody here may be.
The first and foremost requirement is you need a highly reliable rocket, because safety of the human being carried and brought back is the most important point. So for a manned mission, you require a rocket with a reliability of 0.99, one failure out of 100 you can tolerate. You need to take this crew up, and while going up, if anything happens to the launch vehicle, you need to have an escape system, which must have a reliability of 1 order better, 0.99 each. Then we need to have the environmental control life support system for keeping the crew in the crew module. That has to be developed and qualified, because we should be able to stay there and stay for 7 days or more than that we need to plan. And as they come, we need to bring them back. And also these astronauts have to be trained. The launch pad facilities have to be there. So when I talk about a rocket or a satellite of that class, design, fabrication, testing, all these get into a new class. So easily 7 to 8 years would be required from where we are today to get into a mission. And it goes through a series of testing in unmanned way as well as the manned way.
7 to 8 years, meaning you seem to have a go-ahead from the government?
What we have today is to look at the critical technologies which are required, that is wetting our hands with those activities. Number one, we have done this crew module and the re-entry of that. Space suit, we have done some development. Crew escape system, we have done some activities. So that's only to look at those new areas. As I said, wetting our hands. But now we have to get into the program mode and get in a major way to that.
So I'm just curious, you know, we've got American astronauts, we've got Russian cosmonauts, we've got Chinese taikonauts. So what would an Indian be called?
We will leave it to the younger generation of the country to tell us.
But you've thought that there needs to be a name.
Yes, we have thought about it.
Do you have any names which have done the rounds?
Not at the moment. When the program is announced, we will also look at the possible names, the first part of it, how we should put it.
Maybe you should ask on Twitter what would be the name.
Yeah.
That would be a good idea.
Okay,
Maybe
we've
Facebook
got,
and Twitter.
we've got Yuvraj Singh as well, who's got a message for ISRO. Let's just listen into what he had to say.
Congratulate our scientists for making it to Mars. I think it's a fantastic achievement for India, and I wish them all the best in their future ventures, and very proud to be an Indian when you hear such news.
Was it like shooting at a 1 rupee coin which is placed at a distance between Delhi and Bombay? Would that be a good analogy to say when you reach from Earth to Mars?
There are a lot of analogies like JPL director used to tell if you hit a ball from Bangalore to Los Angeles, you should hit that whole far.
Or golf ball hitting hole in one between launch from Bangalore to Los Angeles.
But here the problem is the hole is moving. See here,